Hello students, in this video you are going to learn about different types of transformers according to their construction. First one, transformers are classified into two types according to their construction. So one is core type transformer, other one is shell type transformer. So according to construction, these are classified into core type and shell type. So core type transformer. So you can observe the core type transformer diagram in this figure. So it has two limbs. It has two limbs, and vertical portion is called limbs. Horizontal portion of the is called yoke. So both primary winding and secondary winding placed on both the limbs of the transformer. And in this type of transformer, winding is surrounded by the core. So winding is surrounded by the core. So we can observe the winding how it is placed on the core of the transformer. So primary winding and secondary winding both are placed in both the limbs. So here primary winding is connected to supply, secondary winding is connected to the load. Coming to the second diagram. So in second diagram, so to reduce the insulation cost, so insulation cost, always we need to place low voltage winding near to the core. Here gray color representation is called low voltage winding, and this one yellow color representation is called as a high voltage winding. So this is a low voltage winding, this is a high voltage winding. So in this core type transformer, to reduce the insulation cost, of the transformer, always we need to place low voltage winding near to the core of the transformer, and surrounded by that low voltage winding we need to place the high voltage winding. Next, these core type transformers are suitable for high voltage applications like power transmission, power distribution. So in those cases, so these core type transformers are suitable. And one more thing is, in core type transformer, it has only single magnetic flex path. So this is about the core type transformer. So core type transformer consisting of two limbs. That is called vertical portion, horizontal portion is called yoke. So both vertical portion and horizontal portion is called the core of the transformer. Here core type transformer is having primary winding and secondary winding. The primary winding is, this is the primary winding. The primary winding is and secondary winding placed in both the limbs. Primary winding is connected to supplies, so secondary winding connected to the load. So these two are magnetically coupled but not electrically. So there is no electrical connection between these two windings, but these two are magnetically coupled to the core of the transformer, and it has single magnetic flex path. And these transformers are suitable for high voltage applications. And coming to the second diagram, to reduce the insulation cost of the transformer. So here, so we need to place low voltage winding near to the core of the transformer, and surrounded by the low voltage winding we need to place high voltage winding. So this is about core type transformer. And coming to the second type, shell type transformer. So shell type transformer having three limbs, so two side limbs and one central limb. So both primary winding and secondary winding placed on central limb of the transformer. It has two magnetic flex path. The central limb will divide magnetic flex path into two ways. So that is called pi by 2 and pi by 2. So here we can observe in this is central limb of the transformer. Magnetic flux is divided into two ways. So this is one way and this is another way. So in this type of transformer, the core is surrounded by the winding. In previously, winding is surrounded by the core type transformer. In shell type transformer, core is surrounded by the winding. And next one, in this type of transformer, so near to the core we need to place low voltage winding, and in between low voltage winding we need to place the high voltage winding. So why it is? To reduce insulation cost. If you place high voltage winding near to the core, so the insulation cost of the transformer, what are the insulation material and what are the insulation cost will be increased. So we need to give more insulation to the core. To avoid that one and to reduce the insulation cost, so always we need to place the low voltage winding near to the core, and surround and sandwich between low voltage winding we need to place high voltage windings. Okay, so this is about shell type transformer. And one more applications of shell type transformers are, so these transformers are used in low voltage applications, low voltage power transmission and power distributions, like TV circuits, radio circuits, and electronic device circuits like radar, transistors, amplifiers. Those circuits we will preferable use shell type transformer, since so these transformers are suitable to use only low voltages. So where we are reducing the voltage, primary voltage to secondary voltage, those cases we will use shell type transformer. Okay, so coming to the construction, so these are classified into two types, core type and shell type. So core type, one minute. So core type transformer is having two limbs, two windings, and core type transformers are suitable to use in high voltage applications. So winding is surrounded by the core, and it has single magnetic flux path. So to reduce insulation cost, we need to use low voltage winding near to the core, and high voltage winding surrounded by the low voltage windings. Okay. Coming to the shell type, it has three limbs. So you can observe the differences between these two transformers. It has two limbs. Here this has two limbs, and this has a three limbs. So in this core is surrounded by the winding. So it has it has two magnetic flux path. Central limb is divided into magnetic flux paths in two ways. So it is suitable for low voltage applications, and so similarly, to reduce the insulation cost and how we are using in core type transformer here also. So near to the core we have to use low voltage winding, and surrounded by the sand in between low voltage winding we need to use high voltage windings. So this is about shell type transformer. So this is the one of important question, most expected question in for your VTU examination, external examination. So the question will be asked like this: explain construction of transformers. Otherwise, write the differences between core and shell type transformers. So if they ask any type, you have to write, you have to draw this diagram and you have to explain. So each transformer you have to write minimum 6 to 7 points explanation. Right. And in next video, so we will discuss about EMF equation of single phase transformer. So this is also one of important topic in your syllabus. So they may ask derive the EMF equation of transformer, or problems based on EMF equation of transformer. So these are the one of important topic in your syllabus. So next we will see EMF equation of transformer. Thank you everyone.